Hello and welcome to this presentation on chi-square using Excel. We already discussed about the cell locations concerning the alphabets, the column alphabets and the row numbers. This is a column and this is a row. So what this means is that if you punch the key here, if you punch here, if you click here, it means you are at G9. G9 has this formula B equal to B11 times D9 over D11. If we are here, this is I11 and it is the sum of G11 to H11. That is G11 and H11. So if we double click, you will see what that sum is about. Now, if we come here, that is C10. Now, if we come to these are the observed values, while these are the expected values. Now, one thing to note carefully is that this is a 2 by 2 matrix. You have two rows and two columns, and you have 2 for men, that is graduated and not graduated, and then women graduated and did not graduate. So here you also have the sum D9 through D10. If you double click, it will tell you what has been added there, D9 plus D10. Now, if we come to at this point, the chi-square is about calculating the observed and the expected. There is a general formula for chi-square where you are calculating it manually. Now, if you are calculating it using Excel, this is step 1. Step 2, you get the expected values, and then you get the observed minus expected values, which are the values here, and then you have the observed minus expected all squared. Observed minus expected all squared. Then you have the observed minus expected all squared divided by the expected. These are the values you are having here. If you look at the chi-square formula, this is the procedure, the step-by-step procedure in finding chi-square. So here is the observed minus expected. So if you double click, you will see that this is the subtraction of B9 minus G9. If you double click here, you will have B10 minus G10. If you double click here, you will have C9 minus H9. If you double click here, you will have H10 minus C10 minus H10. Now the values you are having in this column is the square of the values in column A under the expected minus observed minus expected. These subtractions you just did, you just square those values. The square of this gives you this. If you square this, you get this. If you square this, you will get this. That is the implication. Now, the third column here under what you have here, observed minus expected, all squared, all over expected, you will now double click and you will notice that this is B16, that is this all squared, all over G9, which is expected. If you come here, observe under the expected, all squared, all over the expected for men. So here, if you move here, you are going to women now. You are going to have observed minus expected all squared all over H9, which is the value for women. So what this means tells you is that this is men, men, women, women, men, men, women, women. So the chi-square value is what we will now look at, and most of you are asking questions concerning the chi-square value. It is a summation. If you double click this, you discover there is a sum of C16 through to C19. That is the addition of these values 1, 2, 3, 4 gives us the value 54.9409, which is the chi-square the chi-square actual value That is the question somebody is asking me. This is the chi-square actual value sorted out here. So looking at the chi-square actual value, you will have 54.9409. Now, if you go to the chi-square table, usually a table of chi-square gives you an idea. You will compare your calculated value with the table value. And the table value from chi-square table, when you are dealing with degree of freedom of 1, is what you now compare with your calculated value. And you are given the table value, and the table value is 3.84146. I will explain how to obtain table values later, but for now, bear in mind that the table value for chi-square degree of freedom 1, where you will have you will have a value of 3.84146. Now you will compare this calculated Excel value, which is 54.94092. Is it higher than the table value, which is 3.84146? That is number one. Number two, the degree of freedom. Remember, we also said that this is a 2 by 2 matrix. So you are going to have two rows. These are two rows for men and then two rows for women. These two rows for men and two rows for women. So the formula says row 1, that is row for men, minus 1, row for women, minus 1. And there are two rows for men, that is 2 minus 1, and two rows for women, 2 minus 1. 2 minus 1 is 1, another 2 minus 1 is also 1. So that now gives you 1 times 1, which will eventually give you the 1. So this is what I'm looking at. I want you to, let's quickly look at what I'm trying to explain here. Now, if we come to, I'm coming to the Word document which I shared with you, and this is what I'm trying to explain all over here. So you are having, this is the table value from the chi-square table, and this is the calculated value. If you go to this Excel, you will see that the calculated value is 54.9409. So if we come back to this Word document, I'm explaining row 1 minus 1, that is the row for men, which are 2, row for women, there are also 2. So 2 minus 1 will give you 1 times 1, which will now eventually give you 1. Now, the degree of freedom has now been found to be 1. Now, the significance, remember we are in EDU 301, significance value was already discussed. You either calculate 0.01 or 0.05, but in the Faculty of Education, we have adopted to calculate significant values. We place our significant value to 0.05 at 0.05. That is calculating, that is testing your hypothesis at 0.05 level of significance. And this is equivalent to 95% confidence interval. A 95% confidence interval is saying that at least 95% of what you are doing, you are sure of your values. Now, let's go back to the Excel calculation. Look at this value here carefully. You will see 1.2 E minus 13. If you expand this, you will see that the number is getting bigger and bigger. So once you do that, you will see that you are now having 1.24208 E minus 13. And that is the value you will now see back here in this Word document. You will now see the p-value now. The p-value, you have p-value, you have calculated value. This is the calculated value. You compare it with the table value. Calculated value is compared with table value. So orange will be compared with orange, while this value here, will paint it blue, which is 0.05. Let's paint it blue. We'll compare it with this value here, this long value here. Compared with this long value here. Now you have 1.24208 E minus 13, which says that this is in standard form. If you rewrite this number by expressing it away from the study in simple form, no longer in standard form, you are expressing it in full. So this minus 13 means you are moving this decimal point to the left hand side 13 times. So the decimal point was here. So you moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's where the decimal point is. What this means is that this is 0.120124. Now, if you compare this number, you are comparing this number, this one in blue, with 0.05. Now, I asked someone else, if you were to write this number in two decimal places, then this number would be 0.00 in two decimal places. So, is 0.00 bigger or smaller than 0.05? So, 0.00 is actually smaller than 0.05. And when the p-value is less than the significance value, you will reject the null hypothesis. What we're saying is that this calculated value is higher than the table value. That is evidence number one. And this p-value is also smaller than the significance value. That is why you are seeing here both chi-square value, which is this one, 54.94, and p-value, which is 0.00, are extremely strong evidence to reject the null hypothesis. What that means is that you are saying that reject the null hypothesis, which states that there is no significant difference in the graduation rate between men and women. This means that women are graduating at a higher rate than men. Full stop. And how do you go about that? You go back to your Excel, you will see that more women are graduating. See, this is 11,169, while men graduated 10,579. But this difference, is it significant? That is a big question you will ask yourself. Even though women are graduating more than men, is it significant? Is it important? Is it a large difference? Can we consider it to be something we can think about and ask questions and probe further to find out why more women are graduating more than men? So that is the very essence of doing this chi-square calculation in the first place. So you are seeing that if you do difference, for example, let's try to find the difference between, let's say, equal to, let's say, this minus this, that is for men, women minus men, you will see that 590 more women are graduating than or graduated at that time more than men. So your calculation has actually proven that if 590 people are graduating more than the other group, then it means that of a truth, this difference is actually significant. So you may go further to ask questions as to why women are graduating more than men. Are they drinking too much beer? Do they choose to drop out of school and go to farm, or they drop out of school and go and join the mechanic, or do some other handy jobs or stuff? Why women are condensed, they are collected, they keep their heads down and choose to finish school without having to drop out and move into other ventures. So this conclusion is derived from the calculation of the chi-square value, which is compared with the table value, and the p-value, which is also compared with the significance value. So I am hoping that with this explanation, it should throw more light and to the calculation that we have here for chi-square independence test. Thank you very much, and good luck to all of you. If you have more questions, feel free to reach out to me. See you.